In this lesson, we're covering Unit 1, Lesson 3, Evidence of Evolution. If you're following along in the text, I'm on page 28. The essential question that we're going to look at today is what evidence supports the theory of evolution? By the end of this lesson, you should be able to describe the evidence that supports the theory of evolution by natural selection. So the first thing we're going to look at is fossils. On page 30, there's some examples of fossils if you're following along in your book, but we're going to specifically look at how fossils form. Evidence that organisms have changed over time can be found in amber, ice, or sedimentary rock. Sedimentary rock is formed when particles of sand or soil are deposited in horizontal layers. This often occurs as mud or silt hardens. The most basic principle of dating rocks and the remains of organisms inside is the deeper it is, the older it is. The closer to the bottom it is, the older it is. Many fossils form in sedimentary rock. Fossils are the remains or imprints of once living organisms. Fossils form when a dead organism is covered by a layer of sediment or mud. Over time, more sediment settles on top of that organism. Minerals in the sediment then replace the body's material with minerals that harden over time. This product produces a cast fossil. Most often, the dead organism is recycled back into the biological world by scavengers, decomposers, or the process of weathering. So how do fossils change over time? All of the fossils that have been discovered make up what's called the fossil record. By examining the fossil record, scientists can learn about the history of life on Earth. There are gaps in the fossil record in which fossil has not been discovered. We're going to look at how fossils change over time. Fossils that help fill in gaps in the fossil record are called transitional fossils. Fossils found in newer layers of Earth's crust tend to have physical or molecular similarities to present-day organisms. Fossils from older layers are less similar to present-day organisms. So we're going to look at what other evidence supports evolution on page 32 in your text. Many fields of study produce evidence that modern species and extinct species share an ancestor. A common ancestor is the most recent species from which two different species have evolved. Structural data, DNA, developmental patterns, and fossils all support the theory that populations change over time. What other evidence supports evolution? On the left, we have a front limb of a bat, and on the right, we have a front limb of a cat. Related organisms share structural traits. Scientists can compare the DNA from many organisms. The genetic information stored in an organism's DNA gives evidence that the two species most likely share a common ancestor. If organisms develop in similar ways, they also likely share a common ancestor. The study of development is called embryology. So how do we know that organisms are related? I'm on page 34 in the text. Fossils give evidence for how certain species change gradually over time. Fossil and DNA evidence supports the hypothesis that many modern whales evolved from hoofed mammals that lived on land. Scientists have examined transitional characters of extinct species to see how changes happened. Fossil evidence and skeletons of fossils suggest how land mammals might have gradually changed to the aquatic male. Molecular evidence also shows that the DNA of whales and hoofed mammals is